Let's try this. Can you see my screen?
Yes.
Yep. Awesome. Okay, great. So thanks for inviting me, Amit and Timothy. So that's very appreciated. So yeah, well, quick agenda. So don't pay too much attention to the time because I may not respect them. So I'll start with a small introduction about myself. Of course, you're here to hear a lot about myself, so I talk for 73 minutes about that. No, then I will go into the definition, my definition of data strophes, talking about what could be a solution, what are the needs for the solution, and what are the methods that can be applied to find a solution for those data strophes, and then a little bit of showtime with some implementation, as Timothy recalled. So actually, I have to play around with this Zoom window, sorry. So about myself, I'm going to be very quick, right? So I was the creator of the Spark notebook. So I don't know, maybe people don't even remember it. So it was one of the first notebook out there when I created in 2012. It was dedicated to the Scala community, for Spark community. So it was very broad, as you can imagine, especially in 2012. But actually it was very popular because very early, so I had a lot of fun doing that. So that put me in touch with a lot of very nice people, including Timothy. So yeah, that was very great. And during that time, I learned a lot of things about what was missing, I'll say, in the data landscape. That's why I created a company, which is Kensu. So you pronounce it Kensu, for Ken and sustainability, where we create a data intelligence management platform dedicated to AI observability and catalog of data usages. I'm also an author and trainer. So I wrote recently a small report for Rally about what is data governance and the impact on business, where I try to demystify data management and data governance, not about data catalog, but more about the methods and the program that it can be. Also, I'm very proud of this forthcoming training next month, 28th of April, where I'll go in much more detail than in this talk about what can be done in order to monitor machine learning models in Python. Come on. Right here. So data strophes. So what are they? So before giving you the definition, I like to say that, like any project, a data project has to limit its scope, right? So in order to define what is the purpose, what are the goals, not in order to create a project which is going to be multi-purpose and a silver bullet and too many sort of problems to solve. So you'll find your constraints and your topology, let's say, for the project in order to make it short and generate value pretty quick. However, in order to do that, there are many assumptions that are necessary. Assumptions about the market. Okay, so we're going to do fraud detection for only the Visa card in this kind of type of transaction, right? And it behaves like this. So we know that there are fraud in such and such occurrences. And there are other assumptions that will be made also at the engineering during the implementation, which are about the system. My machines are up, the data is always there, etc., etc. And all those assumptions that we always make, right? So we always take decision, and those decisions are based on the assumptions, will lead inevitably to what I call data strophes. So in short, the definition of catastrophe is the denouement of a drama, right? So basically the outcome of a drama. So data strophe is a catastrophe with data, right? So in a way, data strophe is a denouement of a DAMA, right? DAMA being, I don't know if you know it, but DAMA is a data management organization. DAMA.org, they wrote and maintained this famous book. It's a Bible of data management, actually, the DAMA DM book, right? Which is a Bible, really. It's very thick. Very great book, but I mean, when something goes wrong in the data management, right, the output is what I call a data strophe. But some examples. Sorry about my bad drawings, but I'll try to explain as much as I can. So let's take an application. Data is always the output of an application, right? So data is not created, out of nothing, right? So it's created. Sometimes it's from a human who would create input the data into a web form, and then the web form is created the output, right? But the data, not information, is always the result of an application. So which takes an input and produces an output. What are the different things that can go wrong? So come on. So for instance, the input, you can remove one of the columns or JSON field or whatever, right? So when you remove the data, the application might go nuts, it can fail, of course, and then the output might not be produced. Okay, this is one example because the schema changed and the application is not robust against the schema change, it fails, then the output is not generated. So that's one. The second one is not that the data is gone, but you change the definition, right? So you're not reporting the income in a unit, but you report the income in thousands, right? That means that you divide the column values by thousands, right? But then the application still run fine because it still doubles, right? But the output which is created might not be accurate anymore because you may see this kind of chart where you have a kind of scale linear graph like this because the data is totally different than it used to be. So that's another one, and it's a silent one most of the time. Another one is not that there is a human action and there is a change in the definition, but the word is changing, right? And we know that today, more than ever, the word can change drastically, right? And here the value at a specific distribution, it was like Gaussian, right? Let's take the classic, right? And at some point it becomes bimodal, right? The thing is that the application, which can be the computation of KPIs, the training of a machine learning algorithm, or the usage of a machine learning model, right, will still work, right? But what is it producing? Is this still accurate? Is it still fine? We don't know exactly if it's still okay. And if it's not okay on the output side, what is the problem? What do we need to change? The application, modify the application, modify the data? Well, in this case, we can't, right? Do we have to split the data? Do we have to create new application? All these things are the different decisions that we want to take in this kind of case. The other one, which is a classic, the data didn't arrive on the right time. It has not been computed, it has not been ingested, whatever. So the data is old, the application still runs fine, but the output is bad, right? Really, really bad. So it's old and you take wrong decision based on that. It means in a way at this moment, the application is useless, right? So specifically, right, the data is useless, the decision is wrong. So the application would have, if it would haven't, if you won't have, if you don't run the application, then it would have been the same, even better, because then you wouldn't have made these wrong decisions. Another one where you have this kind of wrong decisions is not that the data is changing whatsoever, but you migrate it from system A to system B. That means that the migrated one will still be updated or accurate, but the initial data is not updated anymore. But the person who uses the output and created the application didn't know about it, and it might be full, it sounds weird that I say this, but well, it happens that sometimes application are not known to be using some data, and at the end you don't know exactly if the data is outdated or not as a user, right? Next one is the classic GIGO, right? So garbage in, garbage out, and the garbage is the political version of that let's say excuse, because for me it's more an excuse than the very fact. Actually, the data is garbage, so basically the malformatted whatever, the application still run fine because it's using the data as it's used to do, and the output is also garbage, right? And that's generally one of the excuses that we hear quite often, or we use. To be honest, I use it myself too. Why is my data wrong today? Well, if I take a look at the data, I receive wrong data. What can I do? I give you the wrong data too. But I think that is the wrong approach in a way to justify the data is wrong. But only the data really can create such problems. Actually, there is a famous paper. For me, it's famous, at least. I don't know if that's famous. But no, actually, the data is not the only culprit. And this paper, which is Hidden Technical Debt in Machine Learning Systems, written by Skelly, well, not this Kelly, this one from Google, creates, it proposes this chart showing, okay, you know, the ML code is this little box, black box, maybe on purpose black box here, right, in the middle of all these huge boxes around, which composes the context in which a machine learning code will run, right? And actually, all these boxes are also applications, right? So they can go nuts. They can be, they can fail. They can take assumptions, use assumptions that are falsified at some point in time, which can impact, of course, the quality of the ML code. So not only the data can be a problem, the reason of a data trough, but also many things around it. But with all that, are we at the door of a third AI winter? So I don't know if you knew about the AI winters. So I was born for only one of them. But the AI winter was a period in which many people, almost everybody, was disregarding totally AI, right? It was in the 70s and in the 90s, because basically AI exists since the 50s. But in the 70s and the 90s, a lot of people disregarded AI because it was not able to deliver the promise, basically. And of course, it has been how to say, the A winter finished by the discovery of a method or the technology which is more performant than it used to be in the past, right? But because of data trophies, nowadays we may be at the door of a third winter, in my opinion. The different why we may be at the door of a winter if we don't pay attention to the projects and what we do and the delivery is that there is two things. There is the POC syndrome and there is the ROI of a machine learning or AI system, which is dropping over time. The POC syndrome is very short. You are as a data engineer or data scientist, whatever, you want to solve a problem. So that means that you find somehow some data, you extract or whatever, you create very quickly a POC that delivers the value you wanted to deliver. And then when it comes to deploying in production, it doesn't work because the data is not available in production, or you're scared about deploying in production because you don't know exactly what the data look like in production, right? Because you only got a sample, right? That means that 3 weeks for the POC and 6 months to deploy in production because, well, you know, I'm just trying to get as much accuracy as I can because when it's deploying in production, when it's running live, right? So I don't have any more control on it. And that has an incidence on the ROI because the more you deploy projects and the more they require maintenance in production, checking the quality of the data, checking the quality of the model, checking the quality of the results, checking the health of the data of the application and stuff like that, means that you're increasing your OpEx and reducing, of course, the ROI of your projects. It's not really about garbage in, as I said earlier, but it's really about trusting. Having trust as a person in what is going on in the production, right? And what is going on is the application, right? So the different application running on data. So those data trophies, we need to face them in order to avoid, maybe being out of job in a year or two, something like that. I don't know. So then it comes to AI observability. Sorry, so maybe this is my background, but I see AI through the angle of physics. So, light as a duality, wave and particle, right? So basically it's depending on how you look at it, it will behave differently. And what you want to find in light, it will behave as a wave or as a particle, right? So there is actually the article on Wikipedia is very good at it. There is even a small video showing what it means. But the thing is that Einstein said, there are two different contradictory pictures of the reality when you look at it, right? And actually, none of the, sometimes you have to use one theory, the other time you need to use the other theory, and sometimes you have to use both in order to understand what is going on, right? This is the concept of duality in the light. So it's a particle and it's a wave at the same time. So what is a relation with AI or data in general for me? Actually, a machine learning model can be seen as both a data and an application, right? So why data? Because finally, a model is just a bunch of doubles, right? It has been created, just a bloody matrix that which is used in order to create an application, which is a function that will receive observation, new observation, and create prediction. Does that make sense? Yeah. Okay. So it's data, and if you look at it from its internal state, it's data. If you look at it on how it's used, it's a function, right? That means that, and moreover, the application part, can change and will change depending on which data you will provide to it, right? In order to train it. And the control you have on that is only the parameters, by the way. The thing is, like, the application is like you have deployed, let's say, a Java application, and the code of your Java application changes over time, right? Because the data which is provided, which change the way it behaves, and if you do live training, if it's even worse, right? The model itself changes over time, right? So imagine deploying a code which is changing over time. We are already scared when we deploy something which is fixed. We know the Git hash and everything. So imagine that it changes over time. And this is where AI observability, I think, can be a solution. So observability, very roughly, what is observability is looking at the output of a system in order to understand its internal state, okay? So that's basically what it does. So here there is a picture, there is a person walking to the street with an umbrella. What you hear that is raining like cats and dogs outside. You hear that. You see through the windows, which is steamed, blurry, that there is a poor person working with his or her umbrella, right? However, you take the decision to not go outside and help the person because you see that there is an umbrella part of the system, so it should be fine, right? So you don't have to give help. If the umbrella wouldn't have been there, the person would be running. You may take another decision, right? The system, which is produced through a window, right, which is even not producing the whole data, right, is providing enough information for you to understand what kind of decision you can take, right? You observe the system, right, the output of the system, and you want to act or not on it, right? Is that okay? And actually the cats which are being rained, right, actually Schrödinger cats, right? So you know the story of the cats. This poor cat has died, I guess, 1,000,000 times now. So there is a box, you put a radioactivity particle, you put the poison. If the geyser sensor detects radioactivity, the poison flask is broken, so the cat will die. That means that after a certain point of time, you can consider the cat, well, both dead and alive, right? Because both the radioactivity or the flask can kill it. But actually in AI observability, I know that I'm taking like a long road to go to AI observability, but I think it's interesting to have these two things in mind before digging in what AI observability should be doing. Actually, like for the cat, right, the AI system can be after a certain point of time, certain amount of time, good and bad at the same time. Because catastrophes will happen. I mean, I can tell you, they will arrive, right? So it's not something that may sometimes arrive. No. Actually, is something that always happens because of the assumptions. If it's not systematic based on the system that there is problem, the world will be the culprit. And unless there is an observer that look into what is going on around the AI system, right? You don't know if it's really good or bad at a certain point in time, which is for having, I was in these shoes very often. It's super frustrating. It's a source of anxiety. That means that the only thing you want to do is constantly go to your AI model in the production just to check if everything looks good now, right? That means that you massage the data, you retake the model, you take some data, you produce some results, you look at it, okay, it seems good, okay? Which is, of course, in producing higher OpEx. The thing is, okay, so we need to observe it, but what do we need to observe for AI then? Because it's both data and application, right? Actually, in other words, what are the outputs that will help us understanding what is the internal state of an AI pipeline? In AI, I really consider everything, the data preparation, the data featureization, the model and the prediction, and even other stuff. So again, sorry for my bad drawings, but there are many things that can be extracted automatically from applications, right? When they're running, because what you want to control is your output, your application in a way, right? So actually you want those kind of information at least, right? So you want to control or having a view or observe the structure of your inputs, the stability of your inputs, like if it's complete, if the distributions are still okay, right? If the quality looks good, so your assumptions, if the name has to be first name and then last name, the quality is still okay, or you receive the time, the date time with the time zone and stuff like that. The freshness, so you want to check that the data is still fresh. From the application perspective, you want to expose and make sure that the usage, why this application exists, its purpose is exposed and controlled, right? The metric of the application, the metrics can be the health one, but also the metric of, let's say, what it produces. If it's a training of an algorithm, machine learning models, it will be the metric of the model itself. If it's an AI model, you want to control also which method has been applied, what are the parameters or hyperparameters that were provided to the application in order to see if they are still fine. Also from the outside, from the output perspectives, you want to check some KPIs, which are a little bit different than the the stability. It's more like what I expect the data to produce, look like, sorry, what I expect the data to be in a way, my KPIs. And then, of course, what are the dependencies between my output and the inputs? It's almost there. However, there is also one thing which is often missing in the context, especially of AI machine learning, which is the feedback loop. So I will just take 30 seconds to explain this. If you don't know, I guess you know, but anyway, actually the feedback loop is super interesting in order to make sure that your model, your machine learning model in production is still looking good. Right? In order to check if your model is looking good, you have to see, let's say 2 months after, so you do the prediction, right? And 2 months after, you check the reality of today, so the ground basis, right? With the prediction of 2 months earlier, right? Because you predicted what will happen in 2 months, right? So you check in 2 months, what was the quality of your model 2 months ago, so already you took some period of time where you don't have a good visibility, but the feedback loop is super important for you to understand, well, do I need to change my model? Do I need to work on my project? Whatever, right? If you don't do that, basically, you don't know if your model is still running fine. So what you will have to do is to take some data, blah, 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 as I said earlier. Make sense? Good. Hopefully. Now, there are two circles that I like to represent here. There is the pink one and there is the blue one. There is the circle of influence. This is the circle as me. Let's say I'm the Python writer, right? So I'm writing the Python code. I'm writing the application in the middle, right? So I have almost full control on producing the information about the method I used, the health of my application. I can produce some logs about that. I can create the feedback loop. I can produce the right KPIs for myself, etc., etc. These are the things that I have control on, And there is also the circle of concerns, which is the area where I don't have much control, right? So if the data didn't come at the right time, I don't have control on that. I cannot reproduce it because it's not my input. This is not my data at this moment, right? So if the structure changed, I didn't change it myself, right? I cannot re-add the data which has been removed, right? So it's my concern, right? The thing is that if you want to keep yourself sane, you cannot consider those as part of your responsibility. Otherwise, you will become nuts after 2 months, right? So the thing that you can do, though, in this circle of concerns, and to have a look at it, right? And to have a look at it is because you're using the input data, you can produce your view of the freshness, your view of the structure, your view of the distribution and stuff like that from your own perspective, right? It's pretty much like when you're cooking pasta, you would actually qualify the quality of the water, basically, before you cook the pasta. It's identical, right? And actually, you control the quality of the water because the last couple of months you had dark water every 2 days, right? So basically, because it had happened, well, now you start looking at the quality of the water. So that's just in order to show that from the application perspective, which is creating the outputs, you have a lot of control, right? A lot of control from there. And that's what I think AI observability can be, right? So these are all the outputs that AI observability, at least, should be able to use from the outside world, right? In order to understand what is the state of the internal system, right? Now, checking the time, okay. Some links with the data mesh. I'm not going to dig into data mesh myself, of course, because it would take at least 2 or 3 talks, only open for that, because it's a very passionating theory and methods, to be honest. And currently Zhamak is writing a very fine book that I'm reviewing with O'Reilly, and I'm very looking forward to its release. But there are many concepts that I like a lot in data mesh, and 3 of them are the responsibility, which is given or taken, let's say, by the domain responsible of the data being produced or exposed, right? Being responsible means many things, right? Allowing the data to be discoverable, trustworthy, and so on and so forth. But what is interesting also is that the responsibility can be shared with the consumer. The consumer can provide information about what they expect from the data, why they are using the data, what is the purpose of the data, because there is a relationship that exists between the consumers and the producers. Right? The responsibility is shared, not like, oh, garbage in, garbage out. You asked me the data, I provided you following the business rules, but if the data which is coming is bad, well, I will send beta. That bad data, I'm not the culprit. So that's the attitude that can be resolved thanks to an observability well set up, let's say. Data as a product, it's also linked to responsibility in my mind, but very roughly. So you need to define SLAs, SLOs on the data, and you need to communicate them, of course, or even discuss them with your initial consumers. And I say initial consumers. But actually, if you provide these SLA, you need to be able also to detect when they're not accurate anymore, they are failing, or whatever. So you put yourself in a situation where you need to anticipate such failures as a domain. And federated governance is very interesting also for me, because having a decentralized governance which is responsible for something they don't really understand is not going to work in the world where the data is shared, right? Because if the data is shared, that means that you kind of break the silos, or I like to say you create silos which are transparent, right? That means that you can see through, you can still not access to the data, but at least you can see through, right? That means that you need to have a governance which is composed of different domains, skills, and knowledge in order to have a good view of the system, which we call systemic approach in any ecosystem, for instance. So these are the links that I see with AI observability, because there is a view on how the applications are using the data, producing the data, what is the quality, input, output, and stuff like that. Again, if there are questions, raise your hands. Might not be useful because I won't see it, but make a sound or whatever. So that's all fine by me. So I'm going to dig in the demos. I don't know if there is one or a few things that I need to maybe summarize or explain or whatever at the moment.
We just had one question come up in the chat window, and they were asking if you had a link to any of your upcoming training things, and if you'd be able to share them with the group, perhaps at the end or something, that'd be great.
Okay, so I think it's in the slides. So I will share the slides and it will be there. Otherwise, I will share the link to the training, of course. Okay, if there is anything else, whoops, no. So So what I'm going to run here is a Spark job, right? Python Spark job. So it can be Scala, it can be R, whatever, right? But basically, I'm going to put this back here. So basically, as you understood, because AI is a duality data and application, right? For me, a good way to control both at the right time, at the same time, actually, is from within the application, right? So the application can be responsible of sending information about the input and the outputs, right? Especially because they know what kind of data they're using. So what I'm going to show here is that it's not necessarily hard to do, right? So that's what I want to say. You might think, oh, geez, actually, there's so many things we have to produce. Gonna take a month just to create the right metrics for a specific project. Actually, not necessarily, because it's pretty standard. So we can start coming with some standards that will be shared across projects and stuff like that, in order to produce the right information at the right time. So here, for instance, I have a Python notebook and Jupyter, you know it. So I didn't use the Spark notebook because, well, it's Python. So basically here, it's just a small example where I'm going to read using Spark. You probably all know Spark, right? So I don't have to explain this. We read a database, right? We do a transformation. We just create what we call a segment, right? So we'll just reduce the amount of information to the education non-graduates. So we just reduce the amount of information we get. So the data being about loans, loan requests. And then so I will show it, and then at the end I will write to another database. Okay. So when I will run this, actually there is a library that we will open source in coming month. Actually, so stay tuned. There will be other libraries like that will open source at Kensu to spread the word around. So there is a library in there which has been which is an extension of Spline. If you know Spline, it's a library that allow the Spark DAG to be decomposed somehow, right? But we extended this to add many other features that I will show afterwards. So there is a library that will capture all the different operations that you do on the data in order to create logs. Well, because actually what I was just talking about earlier, all these outputs, they are logs, right? So this is a way you can capture this information and then take a look at it, right? Think about Prometheus, right? It's observability. What do they consume? What is it consuming? Logs, right? Metrics and log, right? So of course I'm just mixing everything up. So when I start this, so I'm going to run it, and actually depending on my connection of VPN, it might take a little bit of time, but basically I just summarize the data here by only taking the information for the non-graduated, and here I'm going to write it. So while I write, actually, a library like this, but of course, I mean, not necessarily ours, because it doesn't need a patent, right? So it's not something that is impossible to be created out of the blue, right? While this thing is running, there are multiple things that are done. On one side, I have to show you this. Where is it? If I can find it, here we go. Actually, in Python notebook, so in Jupyter, you have the capability to create what we call startup scripts. Right? If you don't know what startup scripts is when a Python notebook is started, right? They will run this file first, right? That means that you can create, let's say, bootstrapping methods or whatever. So that's where, for instance, I have created the Spark driver. Whoops, where is it? So I have a function which is creating the Spark driver, right? And actually what we do with our library is that we wrap it up in order to catch events. I will come back to that later, right? And the events are write events in order to create some more logs about what the job is doing. So in this script, we create the Spark driver, and also I get the notebook name. I will catch information like, where is it again? Sorry, here. I'm going to check if the current notebook is in a Git repository. I can get also the Git hash of the current repository in order to build extra information about my notebook, right? And this can be done with Maven, this can be done with SBT, it can be done with setup tools, whatever, right? Just an example here. But the intent is to capture contextual information, right? So later on, you know what has been running, right? That's really the goal here, is to capture information about the application itself, right? And here we start just the driver, so a connector, and we'll see also that it's possible. So there is a method that we tried also using open tracing, open telemetry, that you may know, right? So just a standard, communication for spans, right? So you can use something pretty standard. Again, just an example here. And I hope now that my Spark job is done. So it's done. My data has been written. Okay. So now I can dig into the data that has been produced. So that's what I want to show you, right? So while I wrote this, I created some logs which are stored in the file. So if I write this, so b logs. So I have actually a bunch of JSON that were created. Why JSON? Well, because at least it's structured, right? It's not like string that we have to parse later on, whatever, understanding the structure whatsoever. Okay. And it can be JSON, of course. Protobuf is fine too, whatever makes sense for your communication, right? So it's basically in order to have something which can be produced and consumed with a proper contract. And in the logs here, right, that I show, I'm going to show the first line of log here, right? There are many things that we have captured and sent to the log, the AI Observability server, right? Which is the project name. So actually, the project name is interesting because as application creator, you can tell, look, actually, I'm in the project. This application runs for a specific project, which is fraud detection, churn detection, or proactive maintenance project for this specific piece of whatever, right? You can provide this information, which helps categorizing the application that you're looking at. So you know in what they are participating into. And only the application, only the person who creates the application can really tell, right? There are other stuff that are part of this. And of course, the logs can be long. There are the processes. The processes reports what is the name of the application, right? So currently we are running the AI Observability PySpark.IPNB. So you know that this application, the server will know that the application that this is currently running is this one. Also the code base. So if there was a Git, then you know where the code base is, right? So you know where the data will be, the application will be. The users, it's me, right? So you know who run the application. So you know who you can contact in case of the data strife, right? If the application doesn't produce the right output. The data sources. The data sources are the MySQL, I use MySQL here, input, output that were used and produced, right? So what the data has been consumed, which data has been consumed, and which data has been produced, right? When in this application, by this user, in this notebook, in this Git repository. So imagine the kind of request that you can send to the server then, right? The schema of the data, and that is great. Actually, without having to go on the database, asking for security whatsoever, I know the schema of that bloody database now, and I can control it, right? I can ask someone else to control it for me, right? Just the AI Observability server, right? So if something changed in what I receive, I can rely on this observability system to tell me if something has changed in production, for instance, right? The lineage, you know what lineage is, right? So lineage is a component, it's a structure which, associate, in our case, we associate the relationship that exists between schemas. Schemas of MySQL, schemas of CSVB, right? I will link column to column, right? So that's the intent, right? So lineage nowadays is being implemented all over the places, right? So this is not genius, this is not something new, but the thing is that this is the application when it runs, which create the lineage, right? When the application runs, not because you parse the code, not because you're looking at the data, no, the application tells, look, I am doing that, right? Now, And in there, you'll see that, for instance, you'll see that predict comes from predict, the loan comes from loan, so it's a direct, so nothing great here. And in the group by, we see that actually the date of record, so there is the control dependencies. The control dependencies is what happens in the where clause, right? So we used education non-graduate to modify the values of date record, right? So we filter date record based on education not to graduate, right? So that's why there is a dependency at the control level between these columns. And my favorite are the data stats. Actually, when you run your application, and you can sample, right? So if you have an application that runs every milliseconds, right? While the application is running, this is the right time to compute, to reserve a little bit of CPU time on the data that you have in memory to compute a bit of statistics. The number of rows, the number of nulls, the distribution of column, whatever, right? Because then you have a view on what you're consuming at that time. Not because you have an external scanner which is looking at the data at random times, which is hard then to relate with your application, right? And also it's computing statistics on the whole table, not the data you need, etc., etc. And actually here, there is the statistics for a specific schema during a lineage, which are computed automatically, right? The quantiles, the means, the n rows, the nulls, whatever, right? So you choose. It doesn't really matter, right? What you want as a consumer to be aware of, basically, right? And I share this, so this will be open source. As I said, there are many strategies that can be used for that. One, for Spark, for instance, we use event-based strategy. So the Spark driver sends events when it's writing data, right? That means that we catch this event, we take the DAG, we extract everything out of it, we take the data frame use input output, and we use them to compute statistics. We run extra jobs on the data that we got there, right? And then they are sent. So that's a way, automated, in order to have the data stats on the data input and output, right? There is another fancy way of doing this kind of interpolation, which is using ASM. I don't know if you know ASM, but it's more like ByteBuddy. It's a way to inject code in code, right? It's a bit hackish, but in order to add the function that you miss in the library, let's say in Spark ML, right, which is not sending events when they're writing a model, right, then you can inject some extra code within the method which is existing, right? So I won't dig into this code, but I will deliver also the notebooks, and when we'll open them, of course, you will have access to them. There is already some stuff which is open source, so there will be real stuff being provided out of that. So see, what I wanted to show here is that, and if you want to use, I don't know, Flink, you can use the same strategy. If you want to use Beam, you can do it also, right? Whatever, it doesn't really matter, right? You just have to create this function, put it into your projects, and there is a lot of things that can be done automatically, right? Pandas, I promised Pandas and scikit-learn, right? Pandas, you know it also, I believe, right? So it's pretty classic. Here, I'm going to do something similar. So actually, I'm going to import here. See, there is a little trick that we use there, which is you import pandas, but our pandas, the thing that we have open source, the Kensu dam pandas. You import it as PD, which is the classical way you import pandas, whatever, right? And from there on, you don't need to do anything. Actually, using the strategy that I will show after, you can override all the method of pandas. And again, it's not a lot of work, to be honest, huh? It's not a lot of work in order to intercept what kind of file you're reading, what kind of database you're reading, what kind of Kafka queue topic you're reading, etc., and where you're writing, right? And actually, if you want to do this extra work, you can also capture all the intermediate states in order to see how the columns are combined together, using the group by, using the merge or whatever, okay? I show that right after. So here I'm going to read the species data. Here at this moment, Kensu knows, the library knows, the logs knows that the species data is read. Okay, so there will be in the logs somewhere using this library that you can use. Then I can, oh wait, actually, so this is not needed here. Then I can read the data. This is for circulating afterwards. Here I read the data. I do a little bit of survey subsampling. So I take the 10 first one. So here is like it look like with the tax A, species, and so forth, taxonomy. Concept, and I read another data, which is a obscure URL. You don't know what it is, right? So I read that data also, and then I have this data frame, which contains tax A again, species, and genus, right? I mean, nothing special here. Then I join. So with pandas, I can join, I can merge, I can do many things. So here I'm joining the data, the first one and the second one, which creates this kind of data frame where I have the species ID. You know, I'm actually joining on species ID, right? So I have one species ID, and then I have genus X, species X, tax X, which comes from this one, right? And I have tax A, Y, species Y, etc., that comes from the other data set, right? It's just a join. So I mean, I don't have to explain this, but, and then I save as a JSON, okay? So I've written in this file. The thing is now, in the logs, everything can be produced automatically. So if I show the logs, so there will be many logs created by the library that you can create and use here. But if I show, let's say, the process, again, I will know exactly which process this notebook is. The data sources, so here are the different data sources that were used. So the JSON file has been, the log file is bigger now because I ran it yesterday. But here you see that there is this weird URL and there is this file here. All the different inputs, outputs are reported, the outputs being here, right? And the statistics also are produced. So automatically, in this case, for the species, the input, the statistics of the data are produced, right? And likely for the outputs. The lineage, I'm showing the lineage also here because here you see that there is a link between species ID and species ID, right? But also species X, and species are linked together. Because in data frame, you have full control of what's going on, right? So you know what a merge is. You know what a join is, you know which column you merge on, and so forth, right? So you can create easily the logic in the interceptor that I'm going to show, right? In order to consolidate the links that exist between the thing, right? So in this case, basically what you can do easily in pandas is reconstruct the DAG of your computation, even if it doesn't exist. So I'm showing here the example in pandas. So here we have overwritten pandas data frame. We have provided our delegator, which is overriding the function we want to override, okay? And it extends also pandas data frame, so all the functions are preserved, right? So I guess you know this notation, right? It's basically class, data frame, extend, delegator, and pandas data frames, okay? Sorry. And then at some point, we capture all the functions, the properties, and so on and so forth. And then at some point, we just create the logs that I shown earlier, right? So we extract the data, we extract the data source and we report it. So I'm going to not going to dig into this code because this is pure heuristic, nothing very interesting here. What is interesting for you to get here, what is a strategy that you can use in order to create a library that will be used by everybody without changing much code, right? This is really the key information here. It doesn't take a lot of code, right? So it's like if you take the full class, it's like 254 lines for both pandas and series, data frame and series. So it's not a lot of code, right? So that was for pandas. So we have the statistics, we have the lineage. So that means that if something goes wrong, if you deploy this notebook in production, right, and the output of in this file here, the merge here is becoming weird. Let's say that at some point, because it's an inner join, right? So if at some point there are nulls in species ID of one of these table, right? What happens is that you will have less data, right? because the data will be removed, right? That means that in the AI observability server, you can put some like a predicate or something like this in order to control how much data this Python notebook is producing. And if it's not producing the right amount of data, you can go, you can browse and say, okay, this is what it was, this application, it was this notebook, here is the version, oh, this was the data, what does it look like? Ah, actually, I have the statistics of the data when it ran. Ah, actually, boom, I have many more nulls in the species sub-surveys data set. Ah, good, actually, I know now that the nulls is the culprit most probably, right? Does that make sense? The way you do the root cause analysis based on information that you get. So from the outside information, you can have a view on the internal state, let's say. And you understand that for scikit-learn, it's pretty much the same thing. It's just that the kind of information you want to produce is a little bit different. So in scikit-learn, it's going to be the same process. So we just you just create your own module and you override the different algorithms in this case. So I'm taking the classic Titanic CSV file. I'm reading the data. I'm splitting the data. So basically to run my algorithm. So the train, which will be the observation I will be using to train the first models, and then the test in order to assess if the model is going the right directions or not. The X train looks like this. I have my different features columns, P-class fair. So I will be using this information and the fair information to train a logistic algorithm to detect, if the feature here survived is going to be yes or no, basically, right? So that's a very funny thing to do. So basically here I'm going to subsample, not subsample, but take the feature I want out of the X train data set. So now I have almost 600 rows and 2 columns, the columns that I've chosen. Then I have my Y train, which has the same amount of rows, of course, otherwise it wouldn't work, but only 1 dimension because it's a series. Then I create my logistic regression, I fit it, and this is where the magic happens. Actually, during the fit, right, you can capture the X train, the Y train. You can apply during the fit, you apply the model, and then you catch the model and you compute extra metric on the model at this moment, right? Because it's the right time, right? And generally, as a data scientist myself, I used to have like a pile of code right after in order to compute all my different metrics. And then what I was doing is that I was taking my favorite Excel sheet or paper, and I was writing down the different metrics for the different hyperparameters that I was using, right? Very funny, right? And very easy to also reuse afterwards. Of course, I was being very sarcastic. So my model here is just, I'm not going to do the prediction, otherwise I would run out of time. But basically here, what happened is that the logs that you can create automatically when you had fit your model can be looking like this. So for instance, in data source, I will show you what kind of data source I have, because you can save information about a model that has not been stored, right? So you can capture information about stuff which does not exist anymore because it has been trained in memory, right? It has not been saved, right? You just take the model, right? And actually you can create some statistics about it. So in a way you can create presence about it in your system. The model is a logistic regression. The model training is referring to, hey, actually this lineage, which is using this observation and creating this data set, right? Actually, this is a model training. So you're qualifying what is the purpose of this specific link that exists between data, right? So you can qualify it. It's like tagging. And the metrics are those data that I was talking about earlier, the train explained variant, the score of your model, the MSRE, etc., which are automatically produced because the model has a range of metrics that are worthy for you to control afterwards. That means that if you deploy that stuff in production and you do live training, right? If you have the guts to do that, to be honest. But anyway, if you do that, right, that means that you can produce, two different things. What are the hyperparameters that were used to train the model, and what are the metrics of the algorithm of the model which is being produced at that specific time? That means that, yeah, your code is changing, as I said, like your code is changing in live, right? But at least you have a little bit of control on it. You know what's going on. You know what are the parameters. You know what are the metrics, right? So you can hold off at some point if something goes nuts, like the train score would be like 0.1 or the RSME would be totally absurd, right? It's nothing hard. But the thing is, okay, so when you have this information, great, I can stop it. But how do I solve my situation? Okay, because I want my program to run. I want my output to be produced, right? So how do I find the root cause? Again, it was this notebook at that time with this data. What is the data looking like? Okay, look like that. Okay, about a weird, what is the previous step, etc., etc. So you can browse the information that you can produce automatically from the code using that kind of stuff, right? And again, it doesn't take a lot of time, nor a lot of effort. So I will show you for the linear regression. So beside because this is our library, yeah. But again, so this is this is mostly custom stuff. But here we just extracted the metric of the machine learning algorithm. We have extracted the information about the model, the schema of the model, the schema of the input, the data source of the input, the schema of the input, etc., etc. Everything is consolidated from the fit method that has been overridden. Okay. And actually, we have put it here twice, the duplicated code here. But anyway, so the thing is, it's really simple. And the thing is, what I want to explain here is that I believe that AI observability, which needs information about the data, right? As I said, so application, the data, right? I think that it should come from the application themselves, not from external scanners. So that's why I want to show this, right? Not external scanners are looking at the data using whatever constraints that you can provide yourself. You want to provide your own constraints. I want to control the statistics of this specific data at that moment, and I want to have my own constraints afterwards put in the system because I am the consumer, right? And I can share that with the producer. I can share this knowledge with the producer, right? Because look, actually, I've created this kind of constraints. This is why now my data is not good, right? But it's somewhere. We have the time series, because these logs are happening every now and then. We have the time series of the evolution of the data, output, and so on and so forth, right? That's what is interesting with AI observability, right? Did I say something totally absurd so far, or a question or whatever? Hope not.
Not at all. I think it's fantastic stuff. I'm certainly enjoying it. There are not a lot of comments, so I don't know if everybody else is just in awe or excited or already looking to download some of these libraries that you've helped create, perhaps.
So for the 28th of April, when we'll have this orally training, they will be open source. So you have the results. You have a timeline in a way. So there are other strategies that you can use, of course, using APIs, existing APIs. If you use Tableau, there are APIs about the lineage and stuff like this, so you can consume them. You can also consume information. I liked it. So we tried it a few times and it works very well. Is to use, instead of JSON log or whatsoever, you use telemetry spans. So your code produces spans, but not about URLs or metrics about the system whatsoever. No, it creates spans about the data, right? Spans containing statistics about the data, lineage, etc., etc. So that means that your distributed logs can recompose, what is happening not between applications, but within the application, right? So this, because of course an application it can be very complex. So that's how you can use also telemetry. And we've done this, and this is already available with JAX-R, for instance, ARS. So you can reconnect URLs automatically with files or database or whatever, right? Automatically. So you don't have to do anything. And the JDBC, there is a interesting stuff here that we've done, which is overwriting result set in order to compute the statistics when you iterate over your cursor, for instance.
Fantastic. Have you seen any use cases from capturing these logs with all of this information and stuff about being able to feed that in and do anomaly detection or alerting, you know, for when you have those sort of haywire cases when your accuracy of your model or the input data drops significantly or goes up significantly, and you know that these things are going to influence, you know, the quality of your prediction or of your AI, or just your data pipeline in general, have then been able to put in those alerts and those notifications.
Yeah, all of them actually. That, I mean, all these cases are happening. So one typical case, if you project yourself very far in the pipeline, is from a Tableau. You have numbers presented, very abstracted, right? So aggregated and so on and so forth, right? But you don't know easily if the data which has been used, right, is still accurate or recent, right? That means that you can be notified as someone who has no knowledge about, you know, the technology which is happening, you know, behind the curtains, if your Tableau dashboard can be used to report the financial numbers to the board, right? Because, oh, well, actually, the data is not updated, or something fishy like this has happened with our customer, one of our customer, where they produce information for the customer, so report for the customers, right, about the transactions. It's a bank, right, about transactions. And the thing is, you want to avoid weird data to go to the bank, right? To go to the bank, to the clients, right? And you want to avoid that without knowing much about what the data should look like, because you don't know exactly what the result should be, because this is not your business. So that means that using the variation, the statistics about the data over time, right?
Yeah.
They can anticipate and not send the data to the customers because there is something going wrong in the statistics of the data. They cannot interpret it, but they can at least anticipate having a hungry customer.
And I mean, potentially you could bubble some of that up and even produce data with a confidence rating or something potentially that might also be underpinned by, you know, consistency in the logs or consistency in that stuff potentially as well. Maybe possibilities are endless.
Yeah, exactly. So as long as when you have a lot of data, you can do many things. Huh? So that's why it's great by having this data. But to be honest, if you start producing this kind of data, these are new data. This is data which doesn't exist at the moment in companies, generally where we go, right? Lineage plus statistics all together, you know, this duality, generally it's hard to recombine. You have to use process mining or inference or whatsoever in order to reconstruct something which is known by one asset, your applications, right? So let's provide this capability to the applications themselves. That's what I'm trying to explain here. And to finish, because I have my stuff that will start in 20 minutes, I was, just to summarize, right? So actually stay calm and let your code speak, your tools speak. So let them speak for you. Stop writing the documentation about what you're doing, right? I mean, extra documentation, report, whatever. Actually, there are a lot of stuff that you can generate from the code actually itself. Catching the events, using open tracing, beefing up your libraries, whatever. But this little bit of hard work that you will put forward, right, will help you 1,000 times afterwards, as usual with libraries. Huh? So otherwise, stuff like this wouldn't exist, of course. And there is a link with what I call data intelligence management too. And very shortly on that, you know, data management really often is mixed up with data governance, whatever, why, but anyway. But data governance is something very specific, and itself is really often understood as data catalog for wrong reasons most of the time. But anyway, let's say data catalog is for data governance, metadata, glossary, etc. Actually, data management or data catalog focuses exclusively on the data, right? looking at the data, discovering data, and you can ask questions like, hey, where are the customer data? Okay. The thing is, for me, asking this kind of question is like going to Google and look for a specific website, right? You search for, I don't know, your best website.com, and you look for specific information using Google, which is okay, but actually you know exactly where you want to go already almost, right? The thing is that how we use Google is by providing information to get information, to receive a number of websites of information that might be relevant for the question that you have asked to Google or a search engine like this, right? So by having the information coming in the applications, let's say the project, the purpose, the lineage, and all these things, you can discover application based on the usage. So you can say, okay, how can I predict my churn? And you will find different projects which are about churning. And you will find what kind of data are used to produce churn prediction, right? Instead of looking for prediction data set or customer data set, because you have this extra information that allow you to go outside of AI observability. That's why it's another benefit that we can add to the monitoring purely, I would say. And that's it. So I think I took a little bit more time than I anticipated, but yeah, it's always like that. I'm sorry. I hope that was fine. So, oh yeah, the training is over there.
Great. I think there's a few people that are interested in getting some of those links, and I know you've got other stuff you've got to jump into. But if you're able to perhaps share some of those links, you can either put them on the Meetup page or put them in the chat, or whatever would be fantastic.
Yeah. All the links will slides I will provide. So
oh, great.
Yeah, that'd be great. So I will provide the notebooks, whatever. So I produce everything, so everybody can go dig and hopefully. I'm expecting a lot of feedback and questions, so that'd be great to create something out of it all together. Thanks a lot for inviting me again. So that was great.
Yes, thanks, Andy. Does anybody have any questions? You can either type them in the chat if you're shy, or you can potentially unmute yourself and ask Andy directly.
What I can do is stop sharing, so there is a little bit more room. I have to shoot off in 1 minute, so maybe there is some chat.
Okay.
Yeah, I see the links.
Okay, well, we might let you go. Thanks again for sharing, and it was a great talk. And you've already started me thinking about all sorts of exciting things that I can